Yeah, I am.
All right, go for it.
I'm Matthew Lyon, otherwise known as Matley, and I had originally posted some grand scheme to have everybody send random MIDI messages to my computer over the network and turn that into sound output, and then I realized that was a terrible idea. So I scoped it down, and realizing also that I'm going to be followed by Substack doing presumably some sort of synthesis stuff, I figured I would focus on actually interacting with the outside world with music. I brought a little USB MIDI keyboard with me, and I know how many of you here play instruments? So you know that there's something magical about picking something up that you can interact with and have a really intimate interface with, where you get sound coming out on the other end. And I really like playing with synthesizers a lot, but I find that the interfaces tend to be really lacking. And I know that hardware is a huge focus of this conference as well, so I'm hoping that I can inspire people to hook up hardware to synthesizers or vice versa. Part of doing that is, I guess, a kind of basic overview of the protocols that have been around for musical intercommunication for a while. You wouldn't necessarily want to reinvent the wheel, and if you can build something that hooks up to a standard interface, you can hook it up to just about anything. MIDI has been around for 30 years. It was created by Robert Moog and Dave Smith, among many, many others, and it is a very simple serial protocol for representing keyboard notes and dials on a whatever kind of system, and lots of other things. I'm only going to cover the two really basic ones, which are note events and control events, and I'm going to use a library that's available through NPM as just MIDI. It has interfaces for Mac, Linux, Windows, and it'll need to be compiled, but it works. Note events are really straightforward. Pretty much all of these are 3-byte arrays. The first byte is, they're all 7-bit messages, but the first byte is high bit, so it's 128 to 255, and then the last two are the low bit, 0 to 127. And they communicate a lot of really, some basic information in a very short space. 144 means that it's a note on channel 1. Standard MIDI interface has 16 channels. Given that it's a note, 60 means it's a pitch. It's a middle C on the keyboard. And 100 is velocity, or how hard I hit the key. And I wanted to show some really basic things for having MIDI come through my little interface here and talk to a drum machine that I've got hooked up to Ableton Live. I have some code up on GitHub at matley/nodepdx_music if you want to follow along. And this is, if I need to make this bigger, let me know. This is a really basic thing that sets up an input and an output. It turns those inputs and outputs into streams. I'm connecting to the keyboard here, and I'm creating a virtual output port called Node.js, and simply piping the input of that through a little kind of stream middleware that prints the notes as they come in, and then pipes that straight to the standard out, or to the Node.js output. And so when I hit the when I hit a key, it will trigger something on the drum machine. And that's all fine and well. We've got a little bit of a through, and it's not doing anything. But from here, we can do some more creative things with the notes as they're coming through. So I have a little very simple echo kind of pipe or stream middleware that takes an incoming stream of notes and will echo them for up to 10 times at a really simple rate of, well, in this case, it's got a 125 millisecond delay, and it will reduce the velocity of it by a short period thereafter. And from here, we have kind of a hallway to like some sort of dub type music with a really short echo. If you wanted to create an interface for this, you can have maybe some sort of dial that you're reading from an Arduino, or hell, a web page. It's not all that hard, and I actually have a little web app that displays a web page with some basic controls for controlling this. Whoop. At least it's supposed to. And it's supposed to echo these out. Oh. And it's not. Well, it was working all sorts of times last night. The idea here is that we have some WebSockets that will effectively take the values for the echo time and the echo gain and change them. In a way, I could, you can hook this up to just about anything, and you have at that sort of way you're modifying the stream middleware as it goes on. I'm not entirely sure why this isn't working, but the show must go on. There we go. Yeah, I see that. Well, rather than try and debug live on stage, I will kind of move on. Given that this is a pretty basic pipe, you can interject things in, you can have some effects, and one of the things that I had put in here was a very simple thing that every time I hit the bass drum, it will follow it with a hi-hat a short time later. Because, I mean, why would you want to have a bass drum without a hi-hat? And I don't know if you can hear it very well. But you can program simple little things to help you perform. From here, I also made up a very simple little thing for every beat, and this is 400 milliseconds in this case because we like it fast, it will output a bass note and give us a 4 on the floor with the hi-hat following. And it's kind of a way of just making really simple little machines that will output things for you and hooking them up together. In addition to the notes, you have control events, which are very similar in that they have a control number, which is the second byte, and the value. And beyond this, I had a really kind of straightforward sine wave generator. What this does is for any given, it takes a rate in milliseconds, and it will create a sine wave that goes over that rate. And every 20 milliseconds it wakes up and it will push to this stream some value in the MIDI range of 0 to 127. And I have that hooked up to a filter on the toms on the drum machine. And from here, we should be able to watch the actual filter. And you can create some things to just really help augment performance, but it's outputting this really standard protocol that's been around for a really long time. I was going to get into some stuff about building basically a master clock to drive everything, but as timing is pretty critical to musical performance, and you can't really trust when you do set interval that it's actually going to, or set timeout, that it's actually going to run at that specified time. And ultimately, you want to be able to control tempo based off of some other external source more than likely. But I didn't really feel like I had enough time to get into that. But this is a really basic protocol that's been around for a long time, and there are a lot of things that talk to it. Pretty much any keyboard that you go and find, you can at the store or at the thrift shop, you can get a bunch of old synthesizers that speak this, and hook something up to it. Build little things that generate music, whatever. There's another protocol that was created at UC Berkeley not too long ago called Open Sound Control. It's a UDP-based messaging system. It has a lot more open-ended stuff, and people have been doing some really cool interfaces with it, such as the Monome or the audio cubes that I know Bjork has really kind of popularized. Streams are not really the right interface for doing this kind of thing. You don't need to worry about dealing with backflow or pausing music things. Event emitters are probably the right thing, but what I liked about the concept of using streams for this is how you can use pipe as a way to compose all these different functions. And if you're building something maybe for your kid or for a friend of yours who's not very technical, one of the reasons why pipes struck me as a good interface for connecting various music things is this is effectively an illustration of the last piece I'd put up, where you have input stuff. Oh, totally forgot. One thing from one thing from the fourth patch here is I have another thing that will take our incoming notes and select ranges of them. So the range from 60 to 74, the octave above middle C, it's sending to the drum machine. In the Trial Ableton Live, on channel 2, I have a little synthesizer set up. And the keyboard itself can't do that split. I'm dealing with some hardware that just doesn't know how to deal with this. So I've got a really, really basic stream transformer that takes incoming note chunks, as they will, and based on whether or not the note is within the given range, it will send it on or it will not send it on. This is the note within 60 to 74? If so, then go ahead and send it on to the stream. If not, then it doesn't pass at all. So I can take the low notes and send them to the synth, and the middle notes and send them on to the drum machine. The reason why I think that this is kind of cool is that effectively it's a way of doing functional programming with a stream interface. I've got some really basic functional type primitives for dealing with streams. I've got a filter, obviously, for choosing something to pass on or not, and I've got a map to take incoming things and modify them, or I've got something that takes an incoming thing and does other stuff with it, but then it just sends it on to the next component. And pipe is a really good way for composing these into a single interface. And the reason that this struck out is because this is an interface that's been around in music for a really long time. Before MIDI, you had a bunch of analog synthesizers with patch cords, and this is an interface that people get so easily that it is aped still today. On the top is an analog synthesizer, and on the bottom is a software synthesizer called Reason. And a lot of music and other multimedia programming environments kind of use this same notion of connecting little function modifiers and generators to each other through these kind of fake patch cords. I know that there are a lot of other people talking about functional programming or things like functional reactive programming where you deal with values over time later today. And one of the things that I think as you think about those ideas, maybe consider how you can make those interfaces a little bit more approachable to non-technical people. There are people who get Max MSP and Quartz Composer who could never actually write code without a lot of effort. I did a lot of Perl hacking in the mid-90s, but never really built anything significant until I picked up Max a few years later. And it wasn't until sometime later that I actually got into writing larger things with code. But there are people who do not know how to write code at all that can put together some really complex things with interfaces like this. And if you're trying to build, say, some sort of programmable hardware thing, function composition is through a way of pipes, effectively, is a really powerful abstraction for them. And that's all I have. Sorry for the technical problems.